Okay, root test is very similar. Suppose we have a series with the positive terms. So we could be one thing is called a row. Is equal to the limit when the k approaches to infinity or this k root of ak. See, this row is a number between 0 and 1. Converge to 0. See, it's greater than 1 or infinity, diverge. See, 1, no conclusion. A little bit similar to the ratio test, but the formula is different. It's root test. Okay, this is example 1. In our specific example, a sub m is 1 over m to the m. If you compute, for example, the n root of this expression, n root of 1 is 1, the n root n to the n is just n, and you evaluate 1 over infinity is 0. Therefore, converge it by root test. Example 2 again, root test. So you apply the k root of this expression, k is 3k plus 1 over 5k minus 1, raise everything to the k power. It's obvious k power and k root cancel out, and it's 3k plus 1 over 5k minus 1 without root, without power, and you apply the limit now. When k approaches to infinity of 3k plus 1 over 5k minus 1. It's obvious using dominant case 3 over 5. And 3 over 5 is less than 1, therefore this is zero convergent by root test. Okay, another example of root test. Let's compare the k root of 3k plus 1 divided by k to the 4th power. This is equivalent to say 3 to the k plus 1 divided by k over k raised to the 4 over k. Okay, now let's compare the limit of this. Limit when the k approaches to infinity of 3k plus 1 over k raised to the 4 over k. This is a little bit complicated. Let's do it one by one separately. So you copy like that. Limit when the k approaches to infinity of the 3k plus 1 over k divided by limit when the k approaches to infinity of k raised to the 4 over k. Let's do it now, one by one. Okay, let's compare this limit first. Complete is independent. It's equivalent to say 3 limited when the k approaches to infinity of k plus 1 over k. Okay, and the value for this limit is this limit is 1. That's 3 to the 1 power. This is easy, relatively easy. The other is a little bit more complicated. Okay, let me copy that. This is a limit when the k approaches to infinity of the k raised to the 4 over k. This is infinity raised to the 0 power. This is indeterminate. And see, this indeterminate is the indeterminate you need to apply logarithm on both sides. So it's you call y. apply logarithm of both sides. Of the natural logarithm inside the limit, and 4 over k is a power go to the front as a factor to the k. Now you evaluate logarithm infinity is infinity and over infinity, and 4 is just a number, right? And this is ready to apply L'Hopital rule. Okay, that 4 you put outside the limit. And now you differentiate. Derivative of the logarithm of 1 over k, and the derivative of the k is 1. This is 4 times limit, and the k approaches to infinity over the 1 over k is 0. But this is natural logarithm of y, therefore y1. So the value for that limit is 1. Therefore the answer is 3 over 1 is 3. And 3 is greater than 1. Therefore that series diverges by root test. Okay, this is again you apply root test. K root of the 2 over 3 raised to the k squared. It's obvious 2 over 3 raised to the only 1k, no? Because it's 2 over 3 k squared divided by k. It's just k. Now finally you apply the limit. You apply the limit, and the k approaches to infinity of the 2 over 3 raised to the k power. This is 2/3 to infinity. It's obvious that it's 0 because this number is less than 1, and when you raise to the infinity power, the answer approaches to 0. But the conclusion is this series converges by root test. Good.